the branch of the nervous system that has the ability to send the information to the central nervous system and even also to carry the motor response to the effectors is what we call the peripheral nervous system. Good afternoon to you all. My name is TUMNAD, and today's video we are going to be looking at what we call the peripheral nervous system. Let's go ahead and get started. When we talk about the peripheral nervous system, what's going to be the peripheral nervous system? It is this kind of the system which is going to be sending the sensory information to the central nervous system, and then it waits for the central nervous system to generate the motor response, and then this system also carries the motor response to the far effector structures. That's the general function of what we call the peripheral nervous system. It's going to be sending the sensory information to the central nervous system and then also to carry what we call the motor response. For that reason, peripheral nervous system is going to be having two divisions. The first division is going to be a sensory division. The first division is going to be a sensory. It's going to be a sensory, and because the sensory is taking the information to the central nervous system, it can also be called afferent. Okay, it can also be called afferent. And then the second division is what we call the motor. Okay, is what we call the motor, and this one is going to be responsible for carrying the signals from the central nervous system to the far effector. The fact that the signals are moving from the central nervous system to the far effectors, they are exiting. We also call this one as the efferent. Okay, we also call this one as the efferent. Okay. Now we need to know. We say that the sensory system is going to be feeding the information to the central nervous system. Let's have now a look and see where is it going to be getting those kind of the sensations that are going to be transported to the central nervous system. We have, first of all, the special sense organs. Okay, we have what we call the special sense. Okay, we have what we call the special sense organs. Another one, we have what we call the skin. Okay, we have what we call the skin. Another one, what we call the locomotor system. Okay, locomotor system. Okay, and of course the locomotor system is going to be containing of the skeletal muscles, the joints, the ligament, and all that. And then finally it's also going to be picking sensations from all visceral structures. That is generally what the sensations are going to be coming from to be fed into the central nervous system. Okay, then we need to have a look at some of the sensory fibers which are going to be picking the sensations from these structures. We have a couple of them. Okay, if you remember when we talked about the functional classification of the neurons, we talked about this kind of the sensory and then motor fibers that convey the information to the central nervous system and then also carry what we call the motor responses. The first one is going to be the general somatic afferent fibers. Okay, we also have what we call the general visceral afferent fibers. Then we also have what we call special visceral afferent fibers, and this one is going to be mainly carrying the sensations from like the tongue, or even the nose and all those areas. Then we also have what we call special somatic afferent fibers, and this one is going to be picking sensations, for example, the ears and then also what we call the eyes. Okay, so now these are going to be our sensory fibers that are going to be conveying the information to the central nervous system. Okay, now after the central nervous system has made a decision, we also have what we call the motor fibers that are going to be carrying the information to the far effectors. What are those kind of example fibers? The first one, which is super very important, is what we call the general visceral efferent fibers. Then we also have what we call the general somatic efferent fibers, and then lastly we have what we call special visceral efferent fibers. Okay, so now having seen the sensory part and then the motor part, now the motor division can also be split into two, because we have those kind of motor responses that are going to be under our control, and we also have such kind of motor responses which are not going to be under our control. Okay, that kind of the motor response which we have control over, they are voluntary. Okay, and for that reason, because they are voluntary, they are also called somatic. Okay, they are also called the somatic. Somatic meaning is going to be more of what we call supply to what we call the skeletal muscles. It's going to be a voluntary. It's going to be a voluntary control. Okay, it's going to be a voluntary control. Then we also have such kind of the motor responses that we do not have control over them. In other words, they are involuntary. They happen automatically. For that reason, they are under a division of the motor division which we call autonomic. Okay, which we call autonomic division. Okay, meaning that these ones, they are going to be involuntary. Okay, they are going to be involuntary. We do not have control over them. They happen automatically. And then this kind of the autonomic responses, we have again three kind of autonomic responses which we are going to be having. The first one is going to be what we call the sympathetic nervous system, and then the second one is what we call the parasympathetic nervous system, and then the last one, which very many people don't talk about but is also very important, is what we call the enteric. Okay, the enteric nervous system. The enteric nervous system is going to be found in what we call the GIT, okay, whereby we are going to be having the enteric, and then we have what we call the submucosa plexuses. But of course, this enteric nervous system is going to be working hand in hand with what we call some of the autonomic fibers, autonomic nervous system. Okay, so now we are going to be having now individual videos where we are going to be talking about the sympathetic nervous system. We also talk about the parasympathetic nervous system. We shall also talk about the enteric nervous system. So now, having looked at now the introduction of the peripheral nervous system, so now let's go ahead and see what we call, first compare the somatic division and then autonomic division. Then later we shall go in detail of the sympathetic and then the parasympathetic nervous system in great detail. So now let's compare somatic with autonomic divisions of what we call the motor part of the peripheral nervous system. Okay, so now let's go ahead and see. I want to compare somatic and then autonomic nervous system. We want to see how different are they, but all of them are going to be a division of what we call, they're all going to be coming from what we call the motor division. Okay, because the motor division, we say that it can be, we have those kind of the response that are going to be under our control, which are going to be part of the somatic, and then we said that we have those kind of the motor responses that we do not have control over them, which are going to be part of autonomic nervous system. For that reason, the somatic nervous system is going to be under what we call voluntary control. Okay, it's going to be under what we call voluntary control. That is one of the most important differentiating feature between a somatic nervous system and then autonomic nervous system. Because now autonomic nervous system, its kind of control is going to be involuntary. We do not have control over the autonomic, some of these motor response from autonomic nervous system, involuntary. Okay, involuntary control. Okay, so now this is going to be now a differentiating feature between somatic and then autonomic nervous system. Now, looking at the structures which these two systems are going to be innervating, you realize that for the case of somatic nervous system, it is going to be mainly skeletal. Okay, it's going to be having an innervation of what we call the skeletal muscles. And now when we come to the autonomic nervous system, it is going to be more of the visceral structures. Okay, it's going to be more of what we call the visceral structures. And when we talk about the visceral structures, we have a couple of them. It can be glands, it can be blood vessels, okay, it can be blood vessels, or even it can be what we call the smooth muscles. Okay, the smooth muscles. So now these are the structures which these two systems are going to be controlling. Somatic skeletal muscles, autonomic visceral structures including glands, blood vessels, smooth muscles, and even all other internal visceral structures. Okay, so now talking about the number of motor neurons which are required to come out from the central nervous system to the far effectors. You realize for the case of the somatic nervous system, we only need one motor. We need only one motor neuron. Okay, we need only one motor neuron to come out of the central nervous system to reach the effector organs. Okay, but when we talk about the visceral part, we need two motor neurons. Okay, we need two motor neurons. Okay, we need two motor neurons. And when we talk about the two motor neurons, we have what we call the pre-ganglionic and then the post-ganglionic motor neurons. We shall talk about this one when we are talking about the details of autonomic nervous system. Okay, this also becomes a differentiating feature. What else? Let's look at the chemicals which are going to be produced by these two systems. Which kind of the chemical is going to be produced by the motor neurons when they reach the effector organ, and which kind of the chemicals are going to be produced by these two motor neurons in the case of the autonomic nervous system. Now, when we talk of the somatic nervous system, mainly we're going to be seeing a neurotransmitter called acetylcholine. Now, for the case of the autonomic nervous system, you're going to be having acetylcholine. Okay, you're going to be having acetylcholine or norepinephrine. Okay, or what we call noradrenaline. Okay, adrenaline. So now these are the two main neurotransmitters which are going to be involved in the autonomic nervous system. Okay, we shall again see that in sympathetic nervous system, the preganglionic fibers are going to be releasing acetylcholine, and then the postganglionic fibers will be releasing noradrenaline. And then we shall see again in parasympathetic nervous system that both the preganglionic and then postganglionic are releasing acetylcholine. We shall look at that one in detail when we are talking about the autonomic nervous system. Okay, now these neurotransmitters, once they are released, what are those receptors which are going to be located on those target areas where these neurons are going to be supplying? Now, for the case of what we call a somatic nervous system, it is going to be nicotinic. Okay, it is going to be nicotinic. You may even call it nicotinic M receptors. Okay, you may even call it nicotinic M receptors. But for the case of autonomic nervous system, you're going to be having what we call muscarine. Shall have muscarine, and even also may have what we call adrenergic receptors. Okay, so now that one also becomes one of the key differentiating features. So now are these kind of the neurotransmitters which are going to be released by these two kind of divisions? What kind of the response are they going to cause? Are they going to cause excitatory effect, or they are going to cause an inhibitory effect? Mainly for the case of the somatic nervous system, the response is going to be excitatory. But for the case autonomic nervous system, it can be both. Okay, it is both. We have also what we call excitatory, and then also these neurotransmitters can cause what we call inhibitory. Okay, so now how about if we talk about involvement of ganglion? Now, when we talk about involvement of the ganglion for somatic nervous system, the fact that it's going to be using one motor neuron from the central nervous system to the effectors, we don't need ganglions. So now for the case of what we call somatic, no ganglion. No ganglion. But for the case of autonomic nervous system, we have ganglions. Okay? We have ganglion. And of course, for the case of the ganglions in autonomic nervous system, we have a couple of them. We have what we call prevertebral, and then we also have what we call paravertebral ganglions. We even have some others like intermural for the case of the parasympathetic nervous system, whose kind of the ganglions are going to be even very close to the effector organs. That's why they are called intramural or even terminal ganglions. But for the case of the somatic nervous system, we don't have involvement of the ganglions. Okay, it is also such another cool thing which is going to be differentiating these two systems. Okay, what else? Let's look about the fibers. The fibers which are going to be carrying the information from the central nervous system to the effectors. For the case of the somatic nervous system, it uses what we call general somatic efferent fibers. Okay, and then for the case of autonomic nervous system, it's going to be using what we call general visceral efferent fibers. Okay, these are some of the key differentiating features between somatic and then autonomic nervous system. Okay, so now in the next video, we are going to be now focusing on what we call autonomic nervous system. We go to the detail of the sympathetic nervous system and then the parasympathetic nervous system in great detail. Okay, so now that briefly covers peripheral nervous system, simple introduction with comparison of what we call somatic and then what we call autonomic, which are all part of the motor division of the peripheral nervous system. Thank you very much for watching. It has been TUMNAD all the way from the beginning up to now. And if you think whatever I've just talked is making sense, is adding to you or benefiting, make sure you like the video, comment down in the comment section, and subscribe. Thank you very much for watching. As always, until we meet next time.